Hello everyone. In this video we are going to show how we can calculate out specifically a p-value when we don't have our sample data and when we're only given summary data. Alright, so let's look at this scenario real quick. So it says naturally patients who go to the emergency room wait an average of 6 hours to be admitted into the hospital. The patients in rural hospitals have a lower waiting time. The 13 randomly selected patients who went to the emergency room at rural hospitals waited an average of 5.7 hours to be admitted to the hospital. The standard deviation for these 13 patients was 1.1 hours. Assume the distribution of the population is normal. What can be concluded at the alpha level of 0.1. Okay, so for this study, it's asking what should we use, and we should use a t-test for a population mean. Main reason is because we were given a sample standard deviation, because the standard deviation for the 13 patients was 1.1 hours. And when we set up our null and our alternative hypothesis, since we are interested in means, we are going to be using mu. And we're going to say equals. And then this, guys, we actually think that do patients at rural hospitals have a lower waiting time? So we want this to be less than. And we are going to say that this is 6 hours and 6 hours. All right, so we have our null and our alternative hypothesis set up, and we have a t statistic. Okay, so let's get up our RJ editor set up real quick. And first of all, I'm going to do options digits equals, let's do it 12. That'll be fine. I want to change it just from showing the output only to showing the code and the output. Okay, now I need to put in some values. So the first thing that I'm going to do is I'm going to say mu, which is my null hypothesis. My hypothesized mean is 6. All right, so that's the mean there. I'm going to put in x bar for my sample mean, and my sample mean was 5.7. And my standard deviation was equal to 1.1. And I have a sample size of equal to 13, and we'll set an alpha level of equal to 0.1. Okay, now that I've got those numbers, I can use my equations to calculate this out. So when I do my test statistic, I can calculate out my t-value by saying t is equal to x bar minus mu divided by s divided by the square root of n. And that will give me my t statistic. And I can just put t down there, and then it'll kick it out in my RJ editor. Let's play this real quick. And I get negative 0.98. Let's just make sure that I get this, 0.983, 0.983. Okay, perfect. So I got my t statistic. Now, in order to get our p-value, there's a couple ways that we can do it. Historically, people used tables in order to find it out, but we can actually use Jamovi, and this is actually something that we've already done before. It's just kind of set up a little bit differently. So if we ask the question, it's like, what would be the probability if we were to take another sample and get a result this weird or weirder? We've done that before. And so what we can do is we can actually just come up to distraction and go to our t distribution. All right, so in the t distribution, what we can do is we can use this t value that we got, and it will give us the probability of something this rare or rarer occurring. All right, so I've got my t distribution. My degrees of freedom is not 1. My degrees of freedom is, in fact, 12. And I got that. Let's just add this in here to say degrees of freedom equals n minus 1. And so we can put in degrees of freedom. Let's just run that guy one more time. And so the degrees of freedom are 12. Yep, just so simply remember degrees of freedom is equal to 12. And now we need to compute a probability. Okay, let's compute this probability, and let's put in here negative 0.9833321666036. Probably too many decimal places or like unnecessary. And we can hit enter. And we can see, okay, the probability of being negative 0.983 standard deviations lower than our hypothesized mean. We have a probability of 0.172. And if we look at our p-value, 0.172. And that's how we get that p-value. So that's how you get it kicked out. Yeah, and let's keep on going for the rest of it. So we know that this p-value is greater than our alpha because it is greater than, we had alpha of equal to 0.1, and this is 0.17. So based on that, we are going to fail to reject the null hypothesis. And we would say that this data suggests that, oh, hold on, let's look at this. We would say that the data suggests that the population mean waiting time to be admitted to the hospital from emergency room patients for rural hospitals is not significantly lower than 6 hours at an alpha level of 0.1. So we have statistically insignificant evidence to conclude that the population mean waiting time to be admitted into the hospital from the emergency room for patients at rural hospitals is lower than 6 hours. So that's how you go through and do this if we are just dealing with summary statistics. And this is how you go and calculate out your p-value. Now, if you were dealing this with a z-score, let's say they gave you the population standard deviation, we would do the exact same thing, only with a normal distribution. And we would still just leave the mean and standard deviation the same. You would calculate out your z-score, put that z-score in, compute your probability, and it would kick out your p-value for you. Remember that if you are doing this for a two-tailed example, let's see if we can find a two-tailed example real quick, where we have summary statistics. Let's go and grab, that's a less than. Okay. Let's just do question 3, and instead of doing it as a less than, let's say is different, and I'll show you how to calculate out your p-value here. All right, so let's do one more example. So let's come back up to our RJ editor, and we're just going to update our values here because we're going to need all of these numbers again in order to do this. Ooh, let's do n-1. That's a good one. And we'll change out our alpha. Okay, so the average salary in this city is $45,100. We'll have that be the mu, 45,100. We'll have X bar is equal to 44706. We have an S, a standard deviation of 4710. We have an N, which was equal to 66. We have our degrees of freedom, and we have an alpha level of 0.05. All right, so all I did was I just updated my numbers, and now it'll go through the exact same calculation. So it's kind of handy to have this thing set up because then you can just change out your numbers and it'll kick out the values for you again. And so once again, we are going to select a t-test for the population mean. If we look at our null hypothesis, is mu is equal to 45,100. And for this one, it says less than, but we are going to do a not equals. We are going to make this be a two-tailed test to show how you would get the p-value for a two-tailed test. All right. So let's go ahead and scroll on down, and we'll look at, first of all, calculating out our test statistic. Now, whether it's one-tailed or two-tailed, the test statistic is actually identical. So let's go ahead and run this, and we get a t statistic of 0.6795. Let's just make sure that's what we got. Negative 0.679. Excellent. Now we need to calculate out a p-value. Okay, so let's go to our t-distribution. Let's go back here. We now know that our degrees of freedom are going to be 65 because it's n-1. And let's calculate out our probability, and it's going to be of negative c point, oopsies, 0.67959. That's good enough. Okay, So if we did one tail, let's take a look at our t-distribution. Come down here. So it says that it's going to be, there's a probability of, it's a 25% probability of being just less than 0.6, being less than our t-score of 0.67959. Now, that would be correct if we did a one-tailed test, but we are going to do a two-tailed test. Because we're going to do a two-tailed test, it would be just as weird to see a result that was positive 0.6795 away from the mean. So we actually need to have this area shaded and the area shaded above. So we can do that if we copy this t-score and we're going to put it in here, but instead of it being negative, we're going to have it be positive. And so there are two ways that we can do this. We can either look at the area in between those and take the complement of it to get the tails, or we can just double this p-value. So let me show you what it looks like this. So this is the area in the middle, but we wouldn't be interested in the area in the middle, we'd be interested in the area in the tails. And to get the tails, we could do 1 minus this, which would give us 0.499 would be our probability. Or we can just double the p-value here to get the area of this tail and the area of this tail. So that's how you can do it if you do a two-tail. You have to calculate how weird it would be both from the left and from the right of the distance that our t-value calculated. So that's how we do it if we have sample statistics of how we use our how we can use these sample statistics to calculate out our t-score and then use Jamovi to help us calculate out our p-value. Best of luck to all of you.